Hi, my name is dr. Ahmath. In this lecture, we're going to continue talking about the exponential numbers and the applications in our life. So the exponential numbers has a wide range of applications in our lives. So many things around us can be explained as the exponential numbers or the models which involve the exponential numbers. So in today's lecture, we're going to talk about the applications of the exponential numbers in finance, especially calculating the interest, the yearly interest using the exponential numbers. And we're going to talk about its applications in biology. We're going to see how the population of some animals, or for example, the cells, are going to be increased and how to calculate this. And we're going to talk about a couple of applications of the exponential numbers in the medicine. For example, the modeling the spread of some viruses over the population. So let's start from the first example. The example on a bank. What I would like to know is if I would invest like $1,000 to a bank, deposited to a bank with a yearly interest interest 10%. So probably this number is high, but so 10%, taking its 10% is going to make our calculations a little bit easier. So what does it mean? It means that so if you, let's say in the beginning, 0 is here, so year number 0, year 0, in the beginning, you've got $1,000. So you're going to invest this to the bank, and at the end of this year, or basically in the year 1, you are going to get back your money, but additionally 10% of this, because you deposited this money to the bank. So let's calculate this. So it's going to be, you are going to get back your money, 1,000, plus the 10% of this. It's going to be 1,000 times 10 divided to the 100, right? So this is 10%. So it's a 10th portion of the 100. So if you take out 1,000 out of the brackets, it's going to be like 1,000 times. So I need to put here 1 because you take out the 1,000 itself out of the brackets. And so that the multiplication of the 1,000 is a 1, it's going to give you this 1,000. Plus, if you take out this second 1,000 out of the brackets, it's going to be simply 0.1, right? Because 10 over 100 is going to be 0.1. So if you add the numbers inside the brackets, it's going to be 1.1. So the number here is going to be 1,000 times 1.1. So basically, after 1 year, you're going to have $1,100, right? And here, the idea of calculating this is basically, so if you would have just $1,000, right? So if you would like to add up the 10% to this, what you just need to do is you just need to multiply your 1,000 to the 1.1. So it works always. So the idea is explained here in the intermediate steps. So what I would like to do is, like in the year 2, I would like to know, hey, how much money I'm going to get. So if I would just invest the money, which I took at the end of the 0 year, so in the year 1, and just deposit this money back to the bank, how much money I'm going to have at the end of the first year or in the year 2. So this is going to be a 1,000 times 1.1. So this is the money which I've got previously, right? And I have reinvested this. And additionally to this, I need to get, like, so this number is going to be increased to the 10%, right? So this is going to be multiplied to the 1.1. So I hope that you understand why we're multiplying this as 1.1. So if not, let me explain you this one more time. So basically, now you have $1,100. So you are going to invest the $1,100, right? And plus, you are going to get 10% of this. So which is basically, so the 10% of this is $110, or you can calculate this as multiplication of the 1,100 to the 10 over 100. And again, we're going to take take out the 1,100 out of the brackets. It's going to be a 1 plus 0.1, which is going to be 1,100 times 1.1. And if you remember, so this 1,100 was just 1,000 times 1.1. right? So basically 1,000 times 1.1, it's the money you've got after 1 year, and 1,000 times this 1.1 and 1.1, it's the money which you're going to get after 2 years. So this is basically going to be 1,000 times 1.1 in the power of 2. So can you guess how much money you're going to get in the year 3? So year 3, it's going to be simply 1,000 times 1.1 in the power of 3, and so on. So if I would just ask you, hey, how much money you're going to have in the year 10, for example, so this is going to be simply 1,000 times 1.1 in the power of 10. And basically, we can calculate, like you can model, for example, how much money you're going to get after like a certain number of the years, and try about your invest strategy, right? Okay, so the exponentials are really used in finance, especially in the banks, in order to calculate the interest of the deposit, but as well the credits and the other instruments as well. So another example of the application of the exponential numbers, which I would like to discuss with you, is the population spread, or the increase of the population of the cells over some time. So another example is going to be in the biology. So let's say you've got a cell which splits to the 2 every hour, let's say every 1 hour. So cell splits to the 2 in every hour. So basically in the beginning, you've got just 1 cell. After 1 hour, so you're going to have 2 cells, right? So after 2 hours, so every 2 of your cells are going to be split into the 2 again. So this is going to be 1, 2, 1, 2, right? After 2 hours, the number of the cells here, so in the beginning it was just 1, then after 1 hour it's like 2, after 2 hours it's 4. Can you guess how many cells you're going to have after 3 hours? So every 4 of your cells is going to split into the 2. So this is going to be basically 8 cells, right? So basically, so if I would like to know what is the number of the cells after t hours, it's going to be simply 2 in the power of t. And indeed, so 2 in the power of 0 is equal to the 1. 2 in the power of 1 is equal to the 2. 2 in the power of 2 is equal to the 4. 2 in the power of 3 is equal to the 8, and so on. So if I would like to know how many cells we are going to have after 10 hours, that's going to be 2 in the power of 10, which is 1,024. So this is again an example of the exponential number in biology. So I can make this problem a little bit difficult. So let's pose the problem. So let's say let's have not just 1 cell, but let's have 30 cells. Okay, so if they split to the 2 every hour, I would like to know how many cells we're going to have, let's say after 5 hours. How many cells we have after 5 hours. Okay, so we know that if I would just have 1 cell, right? So how many cells we would have after 5 hours? After 5 hours, it would be just simply 2 in the power of 5, right? Because every cell is going to be split into the 2. Okay, then at the same time, I have 30 cells, right? 30 cell, let's say. So each of the 30 cells are going to be split into the 2 every hour. And the number of the cells which is going to be generated using 1 cell in 5 hours is going to be 2 in the power of 5, or 32, right? So here it's going to be also 32. So every of the cells are going to be produced 32 of the cells, and in total, is going to be just the sum of all of these numbers, right? So basically, how many terms we have here? 30 terms. So 30 terms, because like for every 30 of the cell. In general, it can be written as a 30 times t in the power of 5, or 30 times t in the power of or 32, right? Okay, so in general, like if you know, so in general, you can write down now the model of degeneration of the cells as the number of the cells after t hours is going to be the number of the initial cells, right, times the t in the power of t. And again, if I say, hey, initially you've got like a 50 cells, how many cells you are going to have after 10 hours? So the number of this is going to be simply 50 times t in the power of 10. So we need to multiply the number of the initial cells to the power of the t. So the idea is because every cell is going to be generated, is going to be split in exponentially. So this is a model which is going to explain us the generation or the increase of the population of these cells. And what the last example, which I would like to discuss with you, is the spread of some viruses. So spread of the viruses, spread of a virus. So let's assume that we've got a virus with the radius 3. What's the radius 3? What does it mean that the radius is 3? It means that every person is able to infect the other 3. Okay, so one person can infect 3 others. So let's assume that in one day. Okay, so in one day, every person can infect the other 3. But at the same time, in the next day, every one of the 3 infected persons can infect 3 others, right? And so on. So in the beginning, I've got just 1 infected persons, right? In the second day, I've got, sorry, not 0, 1. So in the second day, I've got 3 more new infected persons. After 1 more day, it's going to be 9 new infected persons, and so on, right? So in general, the number of the new infected people in n's day, or t's day, is going to be equal to the 3 in the power of t. And indeed, so 3 in the power of 0 is equal to the 1. It's a new cases in the first day, right? So the new cases in the first day is going to be 3 in the power of 1. So the new cases in the second day is going to be 3 in the power of t, and so on. So if I pose the problem like, hey, so how many new cases are going to be, like how many new cases we have after, let's say, 5 days. 5 days, if we have 10 infected, only 10 infected persons. So basically, I've got just like 10 infected persons. I would like to know how many new cases will be after 5 days. So let's try to model this for 1 infected. So if you have just 1 infected, then after 5 days, the number of the new cases is going to be 3 in the power of 5, right? Because so the first day, this person is going to infect 3 new. In the second day, this 3 new cases is going to infect 9 new. Then in one day, this 9 new persons is going to infect 27, and so on. So 3 in the power of 5 is actually multiplication of the 3 to itself 5 times, which is 9 to the 9 times to the 3, which is like 81 times to the 3, 243. Okay, but at the same time, keep in mind, so I'm going to just delete this. Keep in mind that you've got 10 infected, right? So this one is also going to generate 243 cases, and the tens also is going to generate the 243 cases. So in total, you just need to sum them, so 10 persons, right? this is going to be equal to the 10 times 243, which is going to be 2,430 new infected persons in 5 days. So basically, if I would like to know the number of the new cases, according to this exponential model, is going to be the number of the new cases in t's day is going to be n0, which is the number of the cases in the initial cases, times 3 in the power of t. So you may see here that the number of the new cases increases exponentially. And this kind of models, the exponential models, can help us to understand this and predict this. So here are a couple of examples of the exponential numbers. In our next videos, we're going to talk about the radicals and also exponential functions.